Hey, welcome to Number Club. This is Year 1 Pure, Chapter 2, Lesson 3, and today we're talking about functions. So let's get cracking. First up, what's a function? So a function takes a value and gives you an output. It takes an input and gives an output. So it can take an in and it can give you an out. And an example of a really basic function would be multiply by 2 and then add 1. Where if 5 goes in, you get 11 out. If 16 goes in, you end up with 33. Okay? Nice and easy. It multiplies by 2 and then adds 1. You can know an output, for example. You could know 7, take away 1, divide by 2, and get 3 that went in. Functions can work forwards and backwards. If we apply this function to x, we get 2x plus 1. This is called the function applied to x. A lot of the time people call it f of x. The function applied to x is, in this case, to multiply it by 2 and then add 1. Okay? Now, these inputs are my domain. In. Okay? And these outputs are my range. Your domain is the one that says in. It's the one that affects your x's. Okay? The roots of a function, dead simple, the roots of a function are where does that function equal 0. So if this is g of x, for example, then the roots are found when g of x equals to 0. Just a few little notes that you need to know. One is that if this is x, this is the graph of g of x, this is the g of x axis, okay? Really, it should be the graph of y equals g of x. But we've got g of x as one of the axes, and that's really, really important to spot. All right, let's move on. So what happens when you've got f of 5 in this case? Well, f of x equals 2x squared plus 5. So we've got 2 lots of 5 squared plus 5. Well, that's going to be 55. They're dead easy to do, okay? You just plug things into them at this point. You'll have noticed this thing here. X weird E weird R. That is x exists within the real numbers. In other words, x can be, it can be positive or negative. It can be a decimal. It can be a fraction. And now you're probably thinking, well, what can't it be? It can be a 0, that's fine. It can be 0, it's okay. What it can't be is, well, what's the opposite of real? Imaginary. Okay, you don't learn about imaginary in the standard A level. I believe it's in further maths, but it's not part of this course. So really, to all intents and purposes, x exists within the real numbers. Basically, x can be anything that you can think of at the moment. If you want to do some background reading into imaginary numbers, feel free, but it's not required. So we've got g of negative 1. Well, that would be negative 1 squared minus 6 lots of negative 1 minus 3. That would be 1 plus 6 minus 3 equals 4. Job done. Okay. Now, find x such that f of x equals 23. Again, really easy. If f of x equals 23, then this stuff equals 23. If f of x equals 23, I should be able to write 23 there and solve it. So we get 2x squared equals 18, x squared equals 9, x equals plus or minus 3. Dead easy. Really, really, really simple. F of x equals g of x. Well, f of x was 2x squared plus 5 is equal to g of x, which is x squared minus 6x minus 3. Quick pro tip with this one, try to make sure that you've got your positive version of x squared showing, so don't move everything over to the right hand side, even though there's only 2 terms, because you'll end up with a negative x squared. Try to make it so that you produce a positive x squared wherever possible. So we're going to take x squared off each side. We're going to add on 6x onto each side. And we're going to add on 3 onto each side. You get that? Factorise. If you can't factorise, then use completing the square of the quadratic formula. And x equals negative 4 and x equals negative 2. In other words, if I plug negative 4 into this, which gets me 37, I'll get the same as if I plug it into this, which gets me 37. If I plug negative 2 into this, which gives me negative 2, 8 plus 13, I'll get 13 out of that side as well. Okay, let's move on. H of x equals this quadratic. X is within the real numbers, so again, anything can go in. Anything is the domain, it doesn't really matter. express h of x in this form. Now this form is the completed square form. If you don't know how to complete the square, you need to go back to it. So we have x minus 3 all squared minus 9 plus 5. It's in the previous lesson if you're not sure what I'm doing. X minus 3 all squared minus 4. That straight away tells us something. It tells us the turning point is 3, negative 4. And it's often just a good idea to get that written down, just in case you might need it in a bit. Hence or otherwise find the roots of h of x. Hence means you can use this. Otherwise means you could go and you could factorise it if you wanted to. Me, I'm going to use this because I like to use the hence thing if it asks me for it, because often that means that it's given me most of the work it done. So we're going to go with when does this equal 0? Well, it does that when x minus 3 all squared equals 4, which means that x minus 3 is equal to plus or minus 2, which means that x is equal to 3 plus or minus 2, x is equal to 1, and x is equal to 5. So when x equals 1, you get 0 out of this quadratic, which is true, isn't it? 1 plus 5 is 6, take away 6 is 0. Same thing goes for 5. Sketch h of x including all intersections of coordinate axes, so basically including absolutely everything that you can. So h of x, well, will it be u-shaped or n-shaped? We know that u-shape happens when the coefficient of x squared is positive. So it's going to be u-shaped, we know that. We know that you've got roots which are found on the x-axis. They are when h of x equals to 0. So when x equals 1, h of x equals 0. So when 1 goes in, we don't go up or down along the corridor, not up or down the stairs. And we get the 5 there. We know that the y-intercept is 5. And we also know that the turning point was 3, negative 4. One thing you'll spot is that halfway between 1 and 5 is 3. The turning point should always lie on the line of symmetry. So when I draw in this curve here, the line of symmetry would have been there. Okay, your turning point will always lie on your line of symmetry. The line of symmetry in this case is x equals 3. When x equals 3, we get a line of symmetry out of this function. Okay? Give the range of the function. Now the range of this function is, well, the domain was anything could go in. The range is what can come out. Well, can negative 7 come out? If I plug something in, can I get negative 7 out? No, because negative 7 will be down here. If I plug in, say, 1, I get 0 out. If I plug in 2, I'll expect to get something negative out. If I plug in 3, I get negative 4 out. But then it starts to go back up and gets positive. So actually the range is that much there. Okay, so h of x is greater than or equal to negative 4, because it can be negative 4. There's only one way that it can do it. H of x is going to be greater than or equal to negative 4, but also h of x exists within the real numbers. You might be thinking, what would it look like if it didn't exist within the real numbers? So if it existed only within the integers, you might just have a set of sort of points like that. Okay, you don't have the in-between bits. And so there we go. We've got x exists within the real numbers. And if it is just the integers, it'll be h of x exists within, not that one, exists within the integers n. Okay, moving on. Find all real roots of the equation. So to find all the real roots of this equation, we're looking at it and we're seeing, well, this does look a bit quadratic to me. But we know that normally a quadratic would be ax squared plus bx plus c. This doesn't have that, it has something a bit different. Now, c, your constant, your y-intercept, 2, it's fine, that's already done, but the x's seem to have been messed around. Now what I'm going to do is I'm going to look here, right in the middle, okay, and I'm going to match that this here is a problem. I'm going to say that p is going to equal x to the power of a half, which means that f of p will equal, well, we've got negative 3p plus 2, we've got that bit, okay, if p equals x to the half, but also this will be x to the power of, this will be p squared. Think about it. If we've got p squared, if we had p that equals x to the power of a half, well, p squared will be x to the power of a half multiplied by x to the power of a half, which is x. Okay, so it really helps us to look at the central part here, this middle bit, because it's not immediately obvious what p could have been. Now, to solve this, what we're going to do is we're going to solve this here. We're going to find out when does f of p equal 0. And once we find out when does f of p equal 0, we're going to then use that to figure out when does f of x equals 0. So we're going to solve when does f of p equals 0. Where are the roots of this equation? So we have p squared minus 3p plus 2 equals 0. P, we'll go with minus 2p minus 1 equals to 0. And so the roots exist when p equals 2 and when p equals 1. Okay, so the roots of this equation exist when p equals 2 and p equals 1. And we're going to use this to solve f of x, because p was equal to x to the power of a half. So we had x to the power of a half equals 2, and x to the power of a half equals 1. Okay, now if x to the power of a half equals 2 and x to the power of a half equals 1, we can square this, so we can raise it to the power of 2, and we can find that x equals 4. And we can do the same here, and we can find out that x equals 1. Right, you can try it out if you want to. You can plug 4 into that. You can go 4, take away 3 lots of 4 to the power of a half, plus 2, okay, which is going to be 4, take away 3 lots of 2 plus 2, which is going to be 4, take away 6 plus 2, which is 0, okay. These types of questions, they are tricky to do. The main tip that I'll give you is that whatever your x part is here, it can even be that it's like x squared plus, it can even be that it's like some sort of power or something like that in there, okay. That's what you want to substitute in as, okay. That's what you want to pick for your substitution. Very tricky, but it's just a bit of practice and you'll be fine. So let's have a look at some of the looks a bit more difficult. This one says find all real roots of the equation. Now in this case, again, this looks quite quadratic. Look here, this is what I'm going to be using. So I'm going to say that p is equal to 2 to the power of x. And also p squared will equal 2 to the power of x squared, which will be 2 to the power of 2x. Okay, remember this will be 2 to the power of x multiplied by 2 to the power of x, which means you add the powers, you get 2 to the power of 2x. Okay, so g of p will equal p squared minus 3p plus 2. Where are the roots to this? Well, g of p equals 0 when we have p minus 2, p minus 1, so pretty much the same as the last question here so far. But what we now know is that p equals 2 and p equals 1 produce the roots for this equation, for this function, pardon me. But what we said was that p equals 2 to the power of x, so we know that we have 2 to the power of x equals 2, and we have 2 to the power of x equals 1. Now there are other ways to solve this, okay? There are other ways to do it other than what I'm about to show you, and they come up later on during your A level, okay? They come up when you start to learn about exponentials and logs. But in this case, what you should see is that it's pretty obvious that x is going to equal 1, because 2 to the power of 1 is 2. So x equals 1 is one of the solutions. And it's also pretty obvious that 2 to the 0 equals 1. And so x equals 0 is another one of the solutions. Okay, they're not overly complicated, but when you do get to the more difficult ones, using this same skill really, using this kind of looking at the middle term and swapping, you'll be able to deal with these with exponentials and logs, which will be a bit more fancy, but that's later on in the course. Okay, moving on. Here's our exam question. So it looks pretty horrible. It's got this thing here. So solve algebraically, blah, 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 blah. I'd expect that you probably pause the video. So I'll pause myself and then I'll go through it. Okay, let's crack on. So the first thing is that we've got this bit here. I'm going to say that p is equal to 8 to the power of x minus 1. Okay, which means that what we've got is p squared minus 18p plus 32 equals 0. Now to factorise this, we need two numbers that multiply to make 32, but also add to make negative 18. Okay. Now, if you can't think of them, list factors of 32 and you'll eventually get there. In this case, it's negative 16 and negative 2. So we get p minus 16 and p minus 2. Which means that p equals 16 and p equals 2 are your solutions. Okay, they're what caused the solutions for this. But we also said that p is equal to 8 to the power of x minus 1 is equal to 16, and we've also got 8 to the power of x minus 1 is equal to 2. Alright, now to solve something like this is not very simple. This side is much more difficult than this one. We need to figure out what power of 8 is 16. To do that, we can say that 16 is equal to 8 multiplied by 2. So that is 8 to the power of 1 multiplied by 8 to the power of 1/3, because 2 is a cube root of 8. So what we now know is that 8 to the power of x minus 1 is going to equal to 8 to the power of 4/3. 16 is 8 to the power of 4/3. Promise you that. Now that we know that, we've got x minus 1 is equal to 4/3, which means that x is equal to 7/3. And that's one really nice way to do it. Okay. Another way to do it is you can express everything in powers of 2. So I'll show you what that looks like. Okay, I'll solve the exact same question, but I'll do it in powers of 2 because some of you might have done it that way as well. So if we've got 8 to the power of x minus 1 equals 16, that's 2 cubed raised to the power of x minus 1 equals 2 to the power of 2, 4, 8, 16, which is 4. Okay, so you get 2 to the power of 3x minus 3 equals 2 to the 4. 3x minus 3 equals 4. X equals 7/3. Okay, so that's another really nice way to do it. There are two ways to really go about that one. Okay, I'll show you this way using the same thing with the power of 2 thing, but you might have done it a bit differently as well. So go back to the same colour it was. We've got 2 cubed raised to the power of x minus 1 equals 2. 2 to the power of 3x minus 3 equals 2 to the power of 1, obviously. So 3x minus 3 equals 1. We're going to end up with 3x equals 4, x equals 4/3. Okay, there's your exam question done. Not an easy one, but definitely an interesting one. Thanks very much for watching. Visit numberclub.org to find more videos just like these ones, and if you get a chance, please subscribe to the channel. Thanks very much.